Hi, this is Mr. Shumway. This video clip practices doing two transformations on a single point and then finding the location of the transformed point. An example would be the point 2, 5 is rotated 90 degrees counterclockwise about the origin and reflected across the line y equals x. Let's find the new coordinates. So 2, 5 rotated 90 degrees counterclockwise. Two, 5. Well, that's assuming that each grid is 1. Here's x and here's y. That's a pretty safe assumption. So that means we're talking about this point right here, over 2, up 1, 2, 3, 4, 5. This point right there. All right, so we're going to rotate him counterclockwise. Counterclockwise is this way, the opposite way that a clock goes. Well, let's just draw a little L. So this shape here, this L here, if I rotate him 90 degrees, he'll still have the same shape. He'll still be 2 by 5. So now the new location of that point will be there. Now I'm going to reflect that about the line, across the line y equals x. Y equals x is this line right here. And so that other point, it's going to come over here somewhere. Well, to find that exact location, I go down 1, 2, 3, 4, 5, 6. Let's see. All right, let's try that again with a larger display. Okay, so go down 1, 2, 3, 4, 5, 6, 7. And I'll be right there. I'll hit that line. So if that reflected image goes, if I go from there back 1, 2, 3, 4, 5, 6, 7, then that's the location of that point. Well, that's easy to see that I should keep going perpendicular, and so it should be the same slope as y equals negative x. Okay, so the locations of this point right here are 2, negative 5. So we started out at 2, 5, and we ended up at 2, negative 5 after two transformations. This one right here is negative 5, 2. So these particular transformations keep the same distance from the origin is one unique thing about them. Let's do 3, 7 is rotated 90 degrees counterclockwise. Let's go to dual page so we can see the description while we try to figure out where it is. Okay, 3, 7. Okay, that point right there. And counterclockwise 90 degrees. So again, we're going that way, 90 degrees. So this shape of an L, 3, 7, will now be 3, 7. 1, 2, 3, 4, 5, 6, 7. So it's at that location right there, across the y-axis. Okay, so here's the y-axis. Oops. Oops. Here's the y-axis. So he's going to reflect across that. So he'll be over here. 1, 2, 3, 4, 5, 6, 7. All right. So this guy that was at 3, 7 is now at 7, 3. still the same distance away from the origin. Okay, so 4, 2 reflected across the line y equals negative x. 0, 2. So that point right there, y equals negative x, is this line right there. And so it'll be over here somewhere. And to find out exactly where it is, from here I come down 1, 2, 3, 4, 5, 6. So I'll go back 6. 1, 2, 3, 4, 5, 6. So right there. And now we're going to rotate 90 degrees counterclockwise. So counterclockwise is this way. So this L shape 2, 4 will now be 2, 4. So the new point will be there. So he's at 2, 4, whoops, negative 4. And he was at, oh no, sorry. 4, negative 2, and he was at 4, 2. Still the same distance away from the origin. All those transformations have that property, those particular transformations.